Hello, sir. Good afternoon, sir. Sam, sir.
Good afternoon, madam. Good afternoon.
We welcome you, sir.
Okay, welcome. Thank you.
கொஞ்சம் ஒரு 5 minutes wait பண்ணணும், sir.
Yeah, sure, ma'am. Sure, yes,
Okay,
sure.
sir. Okay, sir. Ma'am, good afternoon, ma'am. HOD, ma'am. HOD ma'am, good afternoon ma'am. Unmute பண்ணுங்க. Ma'am, good afternoon ma'am.
Sir has come.
Yes ma'am, sir has come ma'am.
Welcome, sir. Dr. Pearlin, sir.
Thank you, ma'am. Welcome, ma'am. Welcome.
Ma'am, participants are 89.
You can start now, madam.
அதுதான் ma'am, 2 o'clock we told ma'am. இன்னும் 1 minute இருக்கு ma'am.
Shall we start?
Shall we start ma'am?
It's up to you, madam.
Okay ma'am. I request HOD ma'am to give welcome address.
You can put the YouTube link also, madam.
Ma'am? Ma'am?
YouTube link also you can put so that students, if they approach.
Yeah, I'll put ma'am. Ma'am, உங்க வாய்ஸ் கொஞ்சம் பார்த்துக்கோங்க ma'am.
Voice கேட்க மாட்டீங்களா?
Ma'am.
Yes, in the maximum only. Okay, good afternoon, dear participants. Welcome to the second session of the webinar series to commemorate International Ocean Day. On behalf of Civil Department, Srm Easwari Engineering College, I welcome Dr. Pearlin Sam, Jinoj, a research scientist from National Center for Sustainable Coastal Management. Welcome, sir. And this seminar definitely will enlighten our students about the opportunities in the coastal management area for the civil students, I hope. Yesterday we had a webinar with Pearlin madam. She was briefing about the water management and its challenges, how we are doing. And today's coastal management also yet another important topic where our students can find out what are the opportunities as well as what is going on in real time. And some of the students from MA also have joined. This talk will be useful for them to go for research on this line. I hope so, sir. Thank you for accepting our invitation and coming for the online webinar. And ours is autonomous college with a department entering the 10th year, and because of the autonomous syllabus we have introduced many lateral courses, interdisciplinary courses. If there is a requirement for this type of water management and this also we can introduce later. You can also give a feedback on that, sir. Thank you for accepting. And Chandrakantama madam.
Ma'am, yes, ma'am. Yeah, ma'am. Over to Stella.
Yes, ma'am. It's my pleasure to extend a cheerful welcome to you all. And now I'm quite excited and feeling great pleasure to welcome our speaker, Dr. T. Pearlin Sam Jinoj. Dr. T. Pearlin Sam Jinoj, done with MTech, MBA, PhD, and also research scientist, National Center for Sustainability Coastal Management, Ministry of Environment, Forest and Climate Change in Anna University campus, Chennai. He attained a research placement at a leading organization in the extensive field of ocean science and technology, including instrumentation, ocean coastal modeling, observational system, etc. His research interests on ocean modeling, hydrodynamic, sediment transportation, spectral wave, environmental ecosystem modeling, oil spill, cyclone prediction and particle tracking, shoreline evolution, etc. He has 8 years experience in research scientist. His PhD research title on development of decision supporting system for coastal protection, a case study for Kaurati Island ocean science and technology. He is experienced with Mike 21 numerical ocean model, hands-on experience with various deployment and mooring of oceanographic instruments in nearshore and offshore sites, in-situ data collection and processing using supportive softwares. Also working experience on various data formats, his publication in international national journals and conferences, conducted workshop and training programs under many organizations. Welcome you, sir, with great pleasure. I request Sir T. Pearlin Sam Jinoj to enlighten the participant with presence of lecture as we begin the evening.
Good afternoon to the study organizers, faculty members, researchers, and students who have gathered here for this webinar series titled Our Ocean, Our Future. Thank you for giving me the opportunity to share about ocean dynamics and modeling to an elite audience like you. As introduced, I am Dr. Pearlin Sam Jinoj. 1 minute, I will share my PPT. As introduced, I am Dr. Pearlin Sam Jinoj, working as a research scientist in National Center for Sustainable Coastal Management. I'm happy to take this topic, ocean dynamics and modeling, to present in front of you. This is the overview of my topic today. Start with the introduction, ocean and coastal dynamics, coastal processes, tools for ocean observation, ocean and coastal modeling, research studies. I'm presenting my research study in the last topic. As we go into the introduction, we know about the ocean. Many of us didn't know that ocean is the major source of oxygen. More than 60% of oxygen we are receiving from the ocean. We know that 2/3 part of the world, Earth is full of the water and the water bodies, including the ocean. More than 50% of world populations are living along the coast, even in India and other countries. More than 50% of population is living along the coast. The ocean influences the weather, climate, and living condition all around the world, actually. Nowadays, we got some news that some glaciers are getting melted, and so the sea level rise is increasing. So it has a direct impact on the climate. The ocean and the climate changes having a link together. In ocean, we can see the stream-like movement of water in the deep sea as well as the surface ocean. Later, we can see the surface current and the deep ocean current. In ocean, the heat is transferred around the world by ocean currents through convection. Many oceanographers know these things. If you want to learn more about the ocean and the convection, the current, how its movements, all this it's come under the oceanography, physical oceanography. Also, over 50.5 of the heat that reaches the earth from the sun is absorbed by the ocean surfaces. We, as industries, are releasing more gases and heat waves, but most of the 0.5%, 50% of heats are absorbed by the ocean surfaces. This is the introduction. Other thing, the ocean is have many various type of marine resources. You may know here I am segmented in 4 parts. Actually, one is physical resources. Physical resources is composed for the mineral deposit, petroleum, natural gases, other thing, fresh water, and many. We can segment many things. Our NAOT, on Neighbor Institute in Palikarnai, they are doing researches on gas hydrates. They are having the ROV vessels to go into the bottom of the sea floor, and they will collect the ocean nodules, manganese, all these nodules. The researchers are going in different institutes. Biological resources, if you compare the NAO, National Institute of Oceanography in Goa, they are collecting too many phytoplankton, zooplankton, microbes and other things, and they are doing researchers. Other resources like energy resources. Energy means from the ocean. In India, we are limited with certain amount, but if we go to the European countries, they are extracting more energy from the oceans, like wind energy, wave energy, offshore wind, wave. We can segment many things actually. Tidal energy. Here I have given a wave power station, what technology they have used in the figure. Other thing is we are extracting some resources like we are using ocean for the transportation and ports and harbors and other recreation. We all visited the beaches to get the calm environment and to get the sea breezes. The recreation, many people are going to different parts of the islands like Lakshadweep, Andaman for their celebrations and other things. So we are using for recreation also. These are the different resources we are extracting from the ocean. With this, I want to link this with the climate change. How we know that the mountains, glaciers are getting melted. If it melts, the water level in the sea get rise, so that many area like in Chennai, if you see our tidal elevation is 1 to 1.5 and the elevation also little high. If we go for other countries and some other places, the elevation are very low. In such area, the water inundate, it will be a great disaster and problem for the livelihood, those who are located in the coastal community. So it is very necessary to look on the climate change factor, even the global warming. Here I have mentioned a graph. This is the snow of Kilimanjaro. You see that 19th century, the total area is around 12.5 kilometers square, but in 20th century, it reduced to 1.5. How it's changing? It's because of the change of climate and all this, the human impact what we make. So we should be very careful. And the next thing is the global surface temperature. Here, this graph it shows in 1880s, the temperature is around 0.2, but in 20th century, we can see the increase in temperature is around 0.6 degree. 0.6 degree. It shows a great impact. Even if using the same data, if we predict from 2000 to 2100, this data is a UNEP data, United Nations Environment Program data. It shows the elevation of the sea level will come around 40 centimeter. They used 3 techniques to standards for deriving this. It shows the maximum is around 100 centimeters. So it is great things we want to focus on to save our Earth and our planet, actually, Earth and the system. With the outset, I'm coming to the pollution. As this is the human and natural impact, we are causing severe damages to the ocean. So I want to touch this also. This is a mandatory thing. We are moving here and there in the coastal area. Whether we are disturbing our country, disturbing our nation, we should think. If we are doing that, means we should try to stop. Here, 80% of pollution is from the land. As a human, we are dispersing the pollution into the sea, and 90% of the floating material is the plastics. You can see number of figures, how we are destroying our nation. And this marine debris, this plastics, it especially kills 1 million seabirds and 1 lakh mammals and sea turtles. You can see more number of sea turtles in that coast, Chennai coast. It's dead in the coastal region. So it's we should be very careful about how we are using our environment. Not only the ocean, even the land part. These are some photos I Googled it. You can see how it is affecting the different species and different system by this actually. Okay, with that, I'm going to our topic, ocean and coastal dynamics. First, Coastal and ocean dynamics is nothing but it's the motion of water within the ocean and the coastal region. Motion of water. The two figures represent water in the offshore region that is the deep sea. Another one is the coastal region. How the dynamics vary. In the deep sea, we can see the high waves, the high wave energy. The wave will be more than 8 to 10 meters in normal seas, and we can during the cyclone we can see it's a high wave around 10 to 15 meters. We can imagine from our home, sitting in the home or office, how the wave, if it is coming 10 meters, means how much the wave will be, how much energy it will have, it is having, we should think. And other thing is, it is, if we take the temperature and the motion, we can segment this ocean into three different things: mixed layer and upper ocean and deep ocean. I'm not going deep into this because this is a major part of the chemical oceanographers. They will take the samples in different places that they analyze the sample. So I'm not taking, but as a civil engineer, I am talking to in a civil engineering manner how it will be useful, how we can think about in future, and how it will be if I am interested in ocean, I want to do some researches on this, how it will be helpful. So in that way, I'm linking this. The primary three important factors which controls the ocean dynamics is the first thing is the current. What is current? It's not an analog or a DC current. This is an ocean current. It's different to normal current, our daily use current. Here, what is ocean current means? It is a horizontal streamline movement of water. Okay, we can see the water, the currents in the coastal region as well as the deep oceans. If we go to the deep ocean, the current is little low, but in the coastal region, the current is very high. This how its form is because due to the weather, the earth rotation and the position of the continents. Why this current is important? Yes, it's important. Many people, because of this current, many people are losing their life. We can a couple of months back in one of the beach in Pune, because of rip current, the foreigners got drowned and some issue was there in Pune. Puri beach. Okay, it's a dangerous one, but it's also helpful to our ecosystem. It moves the tree and drifts the organism place to place, like phytoplankton and other things. It carries the eggs and larvae of and other organism and for the fertilization, and it brings food, and it's change the nutrient dynamics like oxygen and other nitrate, nitric, ammonia, phosphate, all this, and also it will wash away the whatever waste we dump in the coast and it in the deep sea. Okay, its role is different. This is the surface current. Here, the major three factors which control the surface current is one is the global winds. You can see in the picture, the polar easterly current, the westerlies, the northeast trade winds, and these global winds. And the second thing is the continental barrier. We know that different continents, this acts as a barrier. So in between the continents, the currents vary and it's make a different. Later, I will show the warm and deep currents. The third thing is Coriolis effect. This is caused by the earth rotation. If you want to know more about that, you can Google it. You will get the information in a massive manner. The thing is current. The current here in this image, I represented the different kinds of currents in different areas. The red color indicates the warm current. The blue color indicates the cold currents. Red color is the surface current, and the blue color current is the deep water currents. Actually, I will show where it's changing. In this picture, you can see the Alaska, the California, the Peru, East Australian, Agulhas, Equatorial countercurrent, Brazil. These are the different currents. It's based. The name is based on the area which season. In India, we have different season like 4 season. pre-monsoon, monsoon, post-monsoon, summer season. Four seasons are like, if you take as a monsoon period like southeast and northeast monsoon, the current in the ocean is varying, depends on the season. Now, because of the global climate change, we're not able to predict in a particular time the current will be this. We're not able to predict. But this current along the ocean is different, and the major current is the warm and deep current in the deep ocean. The deep current is the stream-like movement of ocean water located below the surface, are called the deep currents. And here you can see the figure, you can see the surface current and the sea current. The equatorial level, the upwelling is happening. Where the deep current is coming to the surface current, that is called as upwelling. Where the surface current is going to the deep, it's downwelling. Here, many changes, the environmental changes is happening in this area. Here, the different kind of phytoplanktons, the nutrients dynamics is changing. In the upwelling and the downwelling region. If you want to know this, you can you can Google it for marine biology, other things. You will get the more information and very good ideas about the biology kind of things in this area, what happening in this upwelling and downwelling region. This is the chain of current flow around the globe. Many of us know this actually, warm surface flow and cool surface flow, how it's flow. In the Indian Ocean, there is an upwelling, and if we go to the Pacific Ocean, there is an upwelling, and if we go to in between the North America and Europe, there is a downwelling. The factors differs. If once we put a ball in the place of Indian Ocean, it will go to the North America, and then it will come back to this Pacific Ocean. This flow will be taken some years. The movement of current is very slow here, but if you come to the coastal region, the current movement is very fast. But here, the current flow is low, but it's very continuous. Okay, this is the first factor. Second factor which induces the dynamics in the ocean is the waves. You know about the waves. Wave is a rhythmic movement that continues, carries the energy through matters or space. This is sample figures. It represents the wave. In the deep ocean, it is high energy waves will be there. It will dissipate at the coastal region. It depends based on the bathymetry. You know, the topography of the earth, that ocean flow. Based on that, it dissipates. Some the bathymetry along the shore, near shore region will be different kinds. More we can segment in 4 different types. It's more technical. Wave hydrodynamics people can know that actually. Okay, I'm skipping to the next. This is the second factor is the wave. The third factor is the tides. Science, we all know about the tides. Tides, how it forms. It's based by the gravitational pull of moon. You can see the spring tide and the neap tide. This is the movement of the moon. It changes. Most of the people consider this as a time. In Tamil, we'll call it Amavasa, Paurnami. Many fishermen know that actually. They used to calculate this day, and they will go for fishing and get number of fishes actually. Based on the full moon, off moon, all this, they will predict that. Even this is a scientific factor, it will be helpful for many things. The tidal range of our Chennai coast, near the Chennai is around 1.5, around 2 meters, the maximum. But if you go to the Gujarat, the western side, the tidal ranges is around 6 meters. In low tide, you can see it looks like a ground, but in high tide, it's look like a river. It's look like even here you can see the differences between the low tide and high tide, and the boat in the sea, in the water, and without the water. During the high tide, the people use that area to navigation. Low tide, they will put off the boat in the beaches. So they used that time as a navigational for transportation, high tide. Even if you go to the Lakshadweep Sea, the elevation is around 1.5 and 2 meters. There it's very difficult to enter into the ocean by the big ships. So the small boats will enter into the islands during only the high tide. The remaining time they will not move because the boat will touch the bottom. All this they will calculate. Even in research community, if you're going into the sea, we will calculate the tide. Which time it's a high tide. That time the wave will be high. So we won't go. Some area we will go. The tide is very important actually. This is happening. The major dynamics in the ocean. Next, we come to the coast. Coast is very important because already in introduction I said that because most of the population are living in the coast actually. So we are disturbing the coast. Some area we are enhancing the coast. So coast is very nowadays people are making so many resorts and other things in the coastal area. So coast is very important. So we should learn. It is good to know about the coastal process also. How we are changing the coast means we are constructing many things without any scientific knowledge. So some aggression, erosion, shoreline change, all this coming along the coast. It's showing a huge impact to the community, local community. If you go to the South India means for Kerala coast, it's full of wave interaction is high. Most of sea erosion is there. How we see erode? In the method, it start because of the waves. The longshore current is the primary factor. What is longshore current? It's a wave comes into the shore, water washes up the beach at an angle, carrying sand grains. And the water and the sand and run straight back down the beach. Actually, this is the figure shows how it moves. Actually, it washes away. The currents in the shores, does along shore current. We have a numerical formula, different numerical formula. We can derive how the currents will be in the shore. If we should know about this actually. It will be depends on the bathymetry. The current will be depends on the bathymetry and the soil texture actually. It's the grain size of the sand actually, which plays how much it will be there. The second thing is the rip current. The waves which produce the rip current. As I said earlier, in Puri beach, because of the rip current, that person died actually. You can know how the rip current works. Two longshore currents converges together and takes the person inside the sea. It's very difficult to manage if a person sink into the rip current. It's difficult. We should be very careful. If you are going to beach, we should be very careful and we should look on the currents, whether rip current is there or not before entering into the sea. This is the dynamics. I listed only a few things. The next I'm going with the ocean observation. I'm having an experience to use few instruments. I have used few instruments like this. Depth sounder, transducer, acoustic current meter, echo sounder, tide and turbidity gauge, coastal buoys, meteorological instrument, water sampler, salinometer, telemetry. These are some of the instruments we are using for the ocean observation. Why we want to observe the ocean means we know some dynamics is there. Ocean dynamics in the deep sea and offshore and the nearshore region is varied. It will vary. It's very difficult to find out the solution in the coastal region without observing the condition of the nearshore region. So we will use these instruments and for some times in the sea and some places. It depends on the need of the project, and we will collect the data and we will process. The second part of this presentation is the modeling. In that, we will model how it works. This data will be used in modeling. We will use the numerical parameters formulation, and finally we analyze and we make it as a report, whether this area, this construction is good or not. All this we will do actually. This is the gist of instruments. I am listing few instruments like this. If you want, you go through these instruments. Like First is acoustic Doppler current profiler. This is a current profiler. It measures the current. We can deploy in any depth this instrument. It will calculate, it's based on the input condition, it will calculate the current at each depth of the ocean. Surface, then 1 meter depth, how much current, 2 meter depth, how much, 3 meter depth, how much, it will vary, it will calculate the depth. The working technology is the Doppler effect. It's sent acoustic pulse and returned back. The calculation will depend on the acoustic pulse, reflecting acoustic pulse. The second thing is the Argo flow. It is our INCOIS and NIO, they are using this Argo float. They will take the data, they will launch, deploy using the ships, and they will take the data. Then this Argo float will go into the water up to the depth of 200 meters. It will calculate the temperature, salinity, conductivity, and other parameters also. Then after a few days, 10 days, it will come back to the ocean surface, and it will transmit the data through the satellite to the land station. This is thermocline and halocline. All these features will be calculated based on this data actually. Which area, how much, in order to find the surface current, warm current, change of upwelling region, all this they will calculate using the Argo flow. The second thing is air-sea interaction meteorological. This is nothing but is AWS, automated weather station kind of thing. We can calculate the wind speed, direction, solar radiation, precipitation, and temperature, conductivity, barometric pressure, all the parameters we can calculate this. This will be also helpful in processing and setting the models. This is a biomapper. It will be helpful to find the plankton. It is using the sonar and video techniques. Actually, this is the conductivity temperature depth meter, CTD. Normally we will call it CTD. Here you can see the number of nesting samplers. It's a kind of bottle kind of things. It's a huge setup. We can have a mini setup as well as the large setup actually. Different institute prefer different kinds of, it's based on, here they are deployed in the deep ocean. We can program the instrument using computer at which depth we want to collect the water. Then automatically they will deploy in the sea. If we program for 1 meter means based on the pressure meter, internal pressure sensor, it will open and it collect the water in the single bottle at 1 meter. If you put the value for 10 meter or 100 meter or 2000 meters, based on the depth, it will collect the water. After collecting the water in lab, we will analyze and use for different purposes. The next is gravity corer. This is used to collect the core samples. In the ocean bed, what are the nodules are there, what are the sand texture content, the grain size, what are the nutrient, zooplankton, phytoplankton, all these parameters in sea. Recently we had, 2 years back, we had an oil spill in our Ennur port. That time we used this and collected sediment sample along the Chennai coast. There, in this soil itself, we have found that the oil, the accumulation of oil, settling of oil. So for that purpose, we will use this. This is an echo sounder. This is used to find the bathymetry. So ocean floor bathymetry. To calculate this, we will different kinds of echo sounder are there. Single beam, multi-beam echo sounder are there. It will be used for different purposes. And as well as the swath here in this ship, the broad beam. It will depends on the broad beam and how the depth will be. Different frequency we will use actually. 10 hertz to 500 hertz. Different frequency we will enable to find out the bathymetry in different places. The next is smokeness. It is a it will open and closing net. It will collect the zooplankton samples actually. We use this actually. In this zooplankton sample, we will analyze the microplastic. We have seen our institute has published many papers on this actually. In this species itself, they found microplastics. It's affecting the species. How Humans are making the environment dirty and polluted. We should be careful. This is the ocean bottom seismometer. This will calculate the underwater earthquake. In NAOT, they are using different techniques, the pressure based. If some earthquake happening, like a tsunami, some high earthquake happening the way in the earth floor, the pressure varies in the ocean floor. So it will detect, and the network will be arranged to communicate the signals. It will come to the shore land station, and this area the pressure is getting varied, something is happening. So the group of network will alarm the system. Such techniques. The thing is, this is the sediment trap. Here I am stopping the instruments. This is used to find the sediments in the water samples. If you go to the Lakshadweep, long back, 20 years back, the sedimentation is very high. There is full of good corals reefs are there, but now it's getting disturbed, and most of the corals, the dead corals are there because the people movement, people drastic changes making into the coastal region, its impacts. For finding such things, we will use this sediment trap to calculate all this. Next, I'm going to the modeling part, ocean and coastal modeling. We have seen the dynamics, how the waves, currents, and tides are useful in the dynamics. Also, we have seen the instruments. In this modeling part, we will take all the outputs from the observation and use to predict the condition of the particular area. If I want to know about the condition of the Chennai, we will collect data from Pondicherry and Andhra and different areas, and we are using modeling. We will find out how that waves and energy is coming to the Chennai area, how it's moving. For example, for particle tracking, if you put some particles in Chennai, where it moves, whether it moves to Andaman, whether it's moved to West Bengal, or whether it moves to Indian Ocean, we use the modeling studies. For that, we use the modeling. The modeling is nothing but the dynamic process that exists in the nearshore and offshore region, generated by various drivers. Various drivers means what we heard, that's a current, tides, and waves, storm surges, and other parameters. This right side, the figure shows that is a grid. If you select some region for the modeling, we will make an input condition. We will make inputs like wave, wind, current conditions, formulations, and bed velocity. What is the formula? All this input we will. Okay. In models, there is three things are there actually. One is physical modeling, another modeling, another is composite modeling. Physical model is a laboratory near to Chennai, near to the some dam. We constructed. They had PWS. They are having that small setup with the physical model, how the dam works, how if you this many how will impact flow, how much current is, how much water current will, how flow rate will be there. All these calculations. Calculation is made by physical model. Small, micro, and small, medium, and large scale models to investigate the process. In this figure, that all these are micro physical model, and the numerical model we used by the computer using the codes, open source codes and other softwares, and other using MATLAB software and other Fortran languages, C languages, many languages we will use to derive the numerical model to using the formulas. The composite model, for some cases we will use physical model, some cases we will take the numerical model. That's the composite model. This modeling approach, it includes a number of formulas and other things. We will calculate numerical things, many numerical values, standards to adopt this. Actually, international references will use for the approach. Finally, I am coming with the research study. This is the last thing. This is the study made for the Kavarati Island. You all know some issues going with Kavarati, Lakshadweep in the social media. Lakshadweep is a very good place to visit. I have visited a few times, like for Kavarati. This island is located in the Bay of, not Bay of Bengal, it's Arabian Sea, some mistake. It's a group of islands are there. Only around 9 to 10 islands people are there. Other islands is only for fishing and other things actually. This I have done for the Kavarati Island. You can see this, the entire stretch of the island is only 4.5 kilometers. Okay, before the erosions are, and people in that island is very less. No ship, only not big ship, only small fishes, ship will go there. And the erosions are now some human development structures, some erosion happen in these places. In order to find the system, how work and how the circulation features in that area, will protect this island. We have made some scientific studies actually. And this is the study show reflects the Kavarati island, how it's look like heaven because of all these structures, man-made structures. Now it's getting more eroded. This ecosystem, like the corals and other different varieties of fishes, like it's getting disturbed nowadays. This is the methodology used. Here I have parallelly taken the shoreline for the particular area, and the next thing is nearshore circulation, how and sediment transfer, how it's impact. Here I enabled 3 models like Mike HT model, SW model, Mike ST model. The inputs are wind, bathymetry, wind, tide, wave, current, and what are the constructions there, fishing jetty, western jetty, eastern jetty, seawall, tetrapod, all these. Each model will give suitable output, like Mike HD will give the nearshore circulation, water level, current, longshore current, current speed, all this. Mike spectral wave model, it will give the significant wave height, directions, period. And the SD model, it will give the bed level change, total load, under sediment concentration, and bed load, all this. Finally, we will know the hydrodynamics in this region and how it changes all this. That's the output actually. These are the inputs used. Measures created for the triangular measures, bathymetry and bathymetry, either satellite bathymetry, fine resolution bathymetry used. What are the tidal cycles in the? We can see semi-diurnal tidal cycles there. Actually, tidal elevation in different seasons. These are the sediments are collected along the islands in 5 places. How the sediment sizes vary. This has given as an input to the model actually. We use some instruments to take the data like turbidity, currents, and other things. These are the output for that actually. Then the wind data, we will use seasonal wind data to formulate the output simulation. And these are other data like a current, wave data. It's taken from incoils. These are the output actually. We can see if you give the simulation for a number of days, we will get. Based on that, we will make a scenario for monsoon, post-monsoon, and pre-monsoon season. Which season is showing high dynamics? We will take that season. Based on that, we will suggest suitable structures and particular area like groin is okay, revertments are okay, or detachment, any other things are okay. All this we will derive, and we will make a solution, and we will report it, and we will consider that for the policy or other decision makers. This is one of the things I'm stopping here with. If you have any doubt, actually kindly give me a, unmute yourself and talk actually.
Participants, you can ask any questions if you have. You can post it in the chat box or you can directly ask.
Sir, can we do this sediment analysis through GIS applications?
GIS application, huh? Yes, make it a little louder, please.
Geoinformatics, sir.
Geoinformatics, yes.
Geoinformatics, sir.
Okay.
Remote sensing and GIS.
Yes, yes, yes. In that?
Can we do this analysis, sediment analysis?
Yeah, it's required actually.
Sir, how can we do, sir? Because the satellite,
Yeah.
if we see the satellite images, the pixel will get clumsy. Only we can take the depth, but particle analysis is a very minute. So how can we do the sediment analysis through GIS data?
Okay. There actually we can get some data from the satellite also, but it's not so good actually. It is not true data. Many people, they will go for the place and validate the data. They will collect the sample, and some analyzers are there in labs. Like in our office, we have micro track sediment analyzer is there actually. There we will use. There we will give the sample and we will get the data, and then we use the data for the input of the model actually. The same thing in geoinformatics also. It depends on the projects, and some projects they will ask it will be very clear data should be there. So in that case, we should go to the place and collect the data and analyze. Otherwise, they will use normally with the satellite data. Some data are available in online also, but it will not be very good. Even in bathymetry, whatever data for processing, many data are there. JEPCO, it's a 1 degree resolution, 0.5 degree resolution is there. ETOP data are there, CMAP data are there. All these data are there, but the resolutions are very poor. For some cases, we will take the echo sounder, we will go there and find out the bathymetry chart, and then we will use for the data processing purpose. So it depends on the projects and the time and which projects we are using, how important that project is. Okay, but it is good to take the analysis, lab analysis.
Thank you, sir. Sir, sorry to interrupt. May I ask another question? Because
Yes.
even in field survey, if we collect the data samples,
Right.
even for the same velocity of water, the sample, the sedimentation value keeps getting changed. What I have observed is when I am studying in Vijayawada, they did an analysis.
Okay.
In front of college, there is a river. When they did, the sedimental values will always get, fluctuate. They will fluctuate even the water is still, or if water is still, or even the water is running with some elastic.
Yes, yes, yes. Yeah, it depends on the season. Some area, the soil texture will be changing, grains will be changing. But even in this, what I presented here, the 3 different areas, 5 samples I have taken, but 5 areas is different texture, but we use the average. Likewise, you should, if we are taking from some places, if possible, you will take, it is good to take 4 seasons. Sometimes the current flow is less, the sediment particle size is different. Sometimes the current flow is high, the sediment particle size is very high. So it depends on the time. It is good to take, even that if we are making the simulation for a different season, for different particular season, we should give the input for the particular season. Otherwise, if you are making as a single simulation for the entire year, we can average the data and use. That will be there. Seasonal changes. If we go to, we are simulating for entire India, we are using some average value for all the Indian coast, how the sediment will be there. We are using that as input. If you go to Kakinada coast, that area, the sediment is, the clay type sediment is there. In Marina, the sediment particles is very different actually. Okay, it's a sand kind of things actually. It is very high, sediment D50 value is high. But for simulating entire India, we are using certain limits, and with some, that is some limitations are there. Model simulation, we're using the average value and making a simulation. Likewise, you should do that actually in your researches.
Sir,
Thank you, sir.
Okay.
sir, I want to ask on behalf of students,
Yes.
if they want to pursue higher studies, what is the eligibility, sir, in coastal area, ocean engineering? BE civil engineering is sufficient?
Yeah, if now Anna University there, I think they have stopped this course actually. This course in Anna University because of some limitation. But in IITs and other Andhra University, other area, these courses are there. Even in abroad, many ocean engineering or other things are there actually. So this it is good to join in IITs.
Okay, sir. What is the opportunity, sir, after that placement opportunities? Where will they be placed?
The different R&Ds like NAOT, NAO, our institute and CWPRS institute, like government institutes are there. Other thing is some research labs are there, like DHA, they made for only for the modeling purpose. And Indom or another one company in Chennai is there. Different other industries are there. If we go to foreign, Fugro, major companies there, they are having the nodal point in different countries actually, different countries, Fugro. Many companies are there. Now it's getting, because of in Arab countries for oil rig, for that purpose they are deploying these oceanographers and this kind of people for that for their needs actually.
Okay, sir.
If you have any doubt, I'm giving my mail ID. You can mail me, sam.jinoj actually, sam.jinoj@gmail.com. You can mail me. If possible, I will answer the questions, even for your higher studies or other things. If you have any doubts, you can.
Okay.
Okay.
This area is not well known to students as well as staffs.
Yes.
One of the area, not much exposure we have. And
Yes.
the informations are very useful. Thank you for participating in our webinar, sir. Thank you for coming as a guest.
Thank you.
Of your busy schedules. In online, you have accepted, and this has given us an opportunity to understand the ocean management and coastal management. Thank you, sir.
Thank you.
Nandamma, madam, any
Yes,
other questions from students, madam?
One sir posted one question, ma'am.
Okay.
I'll
It is
just ask.
available in chat box.
Yeah, ma'am.
Sir, please. It
Sir,
is available.
Okay. Yes, ma'am. I'm taking.
Rajendra Prabhu sir asked that, can you tell something about how tsunami waves are created?
Okay. Tsunami waves are created actually. We not how earthquake is forming. We know that the core, what happening inside the core, earth core, what happening. We know volcanoes. We know, but we not predict when it will come, when it won't come. Tsunami waves is causing because of the earthquake under the ocean floor. Okay, it's based on the intensity. The wave it reflects to the shore. The dissipation of wave. If long back it has happened in Indonesia, it's not reflected so much in this area, our area. Okay, some waves it reflecting here, east coast. Some some China area, many Indonesian area, it's very danger to the earthquake zone, even in tsunami, because earthquake under the ocean is there. Because of the earthquake, the wave in that particular area is suddenly peaking and dissipating towards the shore with high intensity. It's around coming around 20 to 30 meters. Also, it's based on the topography. Some kind of bathymetry, it will lose and dissipate the energy actually. If it is the steep slope bathymetry, it will directly hit towards the coast. And that's why we can see the major differences in east coast and west coast. If we go to the west coast, it's very danger. It's very difficult to swim and go into the beach. Many of us, you visited Kerala. but we can go to the east coast like Vedaranyam, Nagapattinam, and all this, and Rameshwaram, all this. It's gentle. The waves will be gentle, and we can swim also in the ocean. That's the difference. It's based on the bathymetry.
Sir,
Madam?
sir,
Yes, ma'am.
you have finished your answer, sir?
Yeah, yes, madam. Yes, madam. Yes.
Okay, sir. Any other questions from anybody? As Sir has shared his mail ID, if you have any doubts regarding coastal engineering, or if you want to go for higher studies like that, you can contact Sir. Okay. Over to Stella.
Yes, ma'am. I would like to extend my gratitude to Dr. T. Pearlin Sam Jinoj. Thank you so much, sir. You made this afternoon session very informative with your expertise lecture. Your lecture about the ocean dynamic and modeling, research studies, methodology was instructional to the participant. We felt great pleasure to have you among us on this time, sir. I would like to thank faculty members and participants for your fullest cooperation. Once again, thank you, sir, for sharing your valuable time with us. Thank you, sir, and thank you all.
Thank you. Thank you.
Sir, thank you so much for accepting our invitation, sir.
Thank you, ma'am, for inviting us.
Thank you, sir.
Thank you.
Thank you so much, sir.
Bye, bye, ma'am.
Bye, sir. Thank you, sir. Ma'am.